In chapter 7, we're going to talk about these objects called relations. And so we're going to need some terminology to get us started with that. We're going to talk about three different ways to talk about how one element of one set is related to another element in another set. So when we have something like A is related to B, in the background, we're thinking that little a is an element of some set A, and little b is an element of some set B. The other way we write this is ARB. In other words, R is the name of the relation that relates A and B. So you're going to see capital letters between two lowercase letters very often in this chapter. The last thing that you'll notice is there's another way to say this, which is the ordered pair AB is an element of R. So we're using this symbol R to kind of mean a couple of different things that are connected with each other. This R is talking about the relationship between A and B. This R is the relation that we are talking about. So what that tells us is that a relation is actually a set. It's a subset of the Cartesian product of the sets A and B. Now, sometimes instead of a capital letter between two elements, we have a symbol. So for example, when we say something like A equals B, we're saying that the A and B are two elements that are related by being equal in value. Another symbol that we sometimes use to represent a relation is the greater than or equal to symbol. This is another example of a relation. Two numbers have this relationship if A is greater than or equal to B in value. Another example is if we take two real numbers that are non-zero, remember the star means they're non-zero, we say that they're related to each other if they have the same sign. So 7.14 and the number E, which is approximately 2.71828, those are related by this relation because they have the same sign. Negative pi and negative square root of 2 are related because they have the same sign. 5 and negative 2 would not be related. A is related to B implies B is related to A, but just in this example, that's not always the case in general. We'll see that in some future examples. So for example, here's one right now. We can say that A is related to B if and only if A is less than B. So 3 is less than 5, that's a relationship between 3 and 5. But I can't switch the position of the 5 and 3 and have it still be true. In other words, if I say 5 is less than 3, that's not true. So in general, just because A is related to B doesn't necessarily mean that B is related to A. So here's another example. We can define relations in words, not just using symbols. So we say let A be a set of students, B is a set of courses. So let's say little a is a student, in other words, an element of capital A, and little b is a course, in other words, an element of capital B. We could say that A is related to B if and only if student A is taking course B. As an example, let's say John Smith is related to Math 210. That would be the same thing as saying John is taking the course Math 210. We can't say Math 210 is related to John Smith because that would mean Math 210 is a person and John Smith is a course. And that's not what we mean by this. So in general, the two sets involved in a relation, the capital A and capital B, they don't have to be the same set. Later on, we will focus on them being the same set, but for right now, in general, they don't have to be the same set. So let's look at the formal definition of a relation. A relation from a set A to a set B is a subset of A cross B, the Cartesian product of A and B. So anything in capital R is an ordered pair AB, where little a comes from capital A and little b comes from capital B. So whenever we say the ordered pair AB is an element of R, we're saying A is related to B, and we also write ARB. So there's that connection we made in the first slide. Quick remark. As we noticed in some of the examples we just looked at, we could replace R with a symbol sometimes, but that's not always available. So we could put a slash through the R, or if there is a relation symbol, we could put a slash through that to mean that two things are not related. You could also use the bar notation. One more example. So now we're going to use the fact that we formally defined a relation as a subset of the Cartesian product of two sets. So let's let R be the set of ordered pairs AB in R2, because remember R2 means R cross R, such that A is less than B. Okay. In other words, AB is an element of this relation if and only if A is less than B. Okay, it's a little easier to read it when we have an actual relation symbol than to write it with the capital R between, but when we're talking more abstractly, we do need that capital R.